one last thing before he starts. If everybody would go to the upper right-hand corner and select speaker view, you will not have this big mosaic of small pictures. You'll see a big picture of Chip and whatever he shares.
Okay, here we go. Okay, let me start here. Hopefully we're in. Come on. There we go. There we go. Okay, I'm assuming y'all can still hear me. I sold vector network analyzers for Hewlett-Packard back in the dim mists of ancient history, and I recall them selling for anywhere between $10,000 and $50,000. I mean, these were extremely expensive, extremely complicated things to play with. What VNA means for people that may not be familiar with it, vector, of course, implies both a direction as well as the magnitude of some measurement. In our particular case, we're going to be talking about complex impedance, which means resistance, capacitance, inductance, all at one time. Network is any electronic system that has one or two or more ports in some cases. And analyzer means it's a comprehensive test suite of tests. And I have to say that I'm stunned by just how comprehensive the suite of tests the NanoVNA is. This is, if you haven't seen this thing yet, this is the $46.99 one on Amazon. It was an open source project by some guys you can look up if you want to, around since about 2016. But a bunch of Chinese cloners have been mass producing these things, driven the costs down, and it's really kind of an interesting story. The first one I bought was literally for $28 from Walmart.com. And I bought it just because I wanted to have a $28 vector network analyzer that I bought from Walmart. I think this is the first time I have ever seen one thing reviewed in both QST and QEX, ARRL's major magazines, in the same month and favorably. That almost puts this into the category of phenomenon, okay? I've been extremely impressed with the support by the community for this thing and the software. This may be one of the finest pieces of testing software I have ever run into, which is kind of mind-boggling. I've been asked about software support. The Windows program seems to be the most complete, but it is supported on Mac and even Android. I've got it running on my cell phone. It's not quite as sophisticated as on Windows, but basically any platform. As a matter of fact, the source code's available, and I have compiled it and got it to run on Ubuntu. So it's available for everything. This has managed to make it to the top of my list of recommended ham equipment. I'll talk about that a little bit more. I probably have, I don't want to think about how many different antenna analyzers and SWR meters and other things I have. This replaces all of them. And again, along with the software, the manual is surprisingly superb, which is interesting. I'm not going to talk a lot about the Amazon advertisement for it. You can look at that for yourself. The one thing I would note is that the basic one that you'll see around has a 2.8-inch screen, which is actually pretty surprisingly adequate. But they have recently introduced a new F version, which has a 4.3-inch screen, which makes, especially with my big fingers, it makes the touch screen a little easier to control. But frankly, whenever I want a big size display, I use the software. It's called NanoVNA Saver is the program. And it gives you much more control, much more sophistication, and as big a screen as you can get on your computer. The 4.3-inch screens, cheapest one I've seen is around $120. Okay, so I'll walk around the hardware here. It uses USB-C for charging and communication. there's a little let's see if you can see my mouse on here, my cursor. This little guy up, somebody nod if they can see me pointing at the thing there. Okay, thank you. That rolls to each side and pushes in. So it's kind of a multi-control. And I thought it'd be a little kludgy, but it actually works quite nicely. So here's the USB connectors there, power switch, of course, 2 SMA female connectors. And I'm going to talk about that just a little bit. Let's see. One of the complaints about this thing that you'll see in all the reviews is that it has 101 sample points, period. You can't adjust that in the instrument, but the software allows you to multiply that by as many segments as you want. And that takes care of the problem. I have played with it with 100,000 test points. Takes a little while, but it works, and it gives you all the resolution you could possibly want. Just to start getting into some of the technical details when we talk about vector network analyzers, you'll see things like this, S11, S21. All that means is S and then the power from the second number to the first number. So in the case of S11, that means it's power from port 1, which is channel 0, to port 1, which is right back to channel 0, so it's reflected power. S11 means reflected. For 2-port testing, for through testing of a filter or a cable or some other device, we use S21, which means the power is from port 1 out and into port 2. Okay? I don't know if I can see questions on this. I don't have my chat open, but if Steve, if somebody pops something, could you let me know? Okay. Oh, one thing I did want to show on that. I highly recommend using a stylus with this. I found this really neat little wrench on Amazon for, I think it was $4. It has exactly the right size to tighten the SMA connectors, and the little round knob on the other end makes a real nice stylus. So, for what it's worth. Quick look at the screen. This screen looks overwhelmingly busy. But it actually, once you start playing with it, even on the tiny screen, it's beautifully organized, makes a lot of sense, and does everything it needs to do. I'm going to take a drink of water here because my voice is going out. Okay, so to start with, down here at the bottom, we have the start frequency and the stop frequency for the scan. You can change that to center and span if that's the way you want to see it. Oops. And that's what, then those numbers would replace that. It has on the device 4 markers that are amazingly useful. In the software, as far as I can tell, you can have an infinite number of markers. It'll get a little tricky playing with them, but anyway. The markers, the active marker, its information is displayed right here. It shows you what the marker number is, what the frequency it's at, so on. And you can see that we've got 4 traces going on here. A Smith chart trace, which is this green one. The blue is a log magnitude trace. The pink is, I have to get in here, phase trace, and the yellow is another log mag trace out of the first port. And all of these markers, see 1, 1, 1, 1, are at the same frequency on each of these traces. So you can grab one of the markers and move it around, see exactly what the measurement is, what frequency it's at. It makes it very useful. This display does not have a SWR trace up, but if it did, you could drag the SWR marker on the SWR trace to someplace you're interested in, and then look at the Smith chart to read off the complex impedance of where that marker is. So it's very sophisticated. So the marker display here shows the current marker and the previously active marker. The trace status is these four things here. And the one that is active has the channel number in the inverse. And then the next information is the characterization of the format, as they call it, which is SWR or Smith chart or whatever. And the scale that the vertical marks are set to, and the current value of the trace. And this little marker here shows that current value. And then finally, the battery status is shown up here. And my experience is the battery is good for about 2 hours of operation on this thing. Just a quick look at the user interface. That's something you really need to play with. I actually tried this. I couldn't figure out any way to hold the device up here by the camera and point at something and move the controls. So I just took some pictures. But at any rate, when you touch the screen anywhere that's not on a trace, it pops up the top level menu, and then you can navigate down through the menus. When you need to enter numbers, it just has a nice touchpad, pops up for the numbers. And if that three-way control on the top of it that I talked about, if instead of touching something, you just push that in, the menu pops up again. This is a block diagram of it. I'm not going to go in a lot of detail here, but there's a couple of comments I did want to make. So the heart of it is this synthesizer chip. And the reason it's important to know a little bit about that is because this is a clock synthesizer. It is not an RF synthesizer. That means the outputs from it are basically square waves. So that is one of the minor issues with using this as a VNA, is you're not working with a real clean sine wave. But for what it's trying to do, the square wave works out just fine. So there's two square waves that come out of that. One goes in to all of the mixers to mix down for the codec to decode. The other goes into a reflection bridge, or a bridge that allows for comparison of the reference going out and the reflected coming back in. And then finally, the through connector for testing filters or cables or two-port devices is the through connector. And this is just an audio codec. It's a fairly sophisticated one, but it makes it fairly simple to code for the thing. It has a Cortex 48 megahertz processor, not particularly powerful, the LCD display, and then that's basically the heart of how it works. The one thing that's interesting on this, if you haven't used the I2C serial control bus, these are all devices that use that, and that makes it really easy, again, to program it. Calibration is important with any VNA and with this as well. To calibrate it, you need a short. You can see the pin here, and this just is literally soldered to the back of the connector. A 50 ohm calibration, this has a resistor soldered in here. The open actually doesn't even have the center pin, and that's the way they use that. One of the things that's a little bit counterintuitive about this, or not immediately obvious, is generally you're going to be hooking this up to a cable. A lot of them, and by the way, I recommend looking for one that includes the calibration tools as well as a couple of cables. The problem is you generally want to calibrate to the end of the cable where you're hooking your device up. And those are typically going to be male connectors. And all of the calibrations that come with it are male connectors. So I actually made a set of my own female calibrators, and that's worked out very well. I'm not going to go through the calibration process. It's a little tedious, but the manual, again, does an excellent job of walking you through it. I recommend it highly. Oops. Hold on a minute. I've got a battery issue here. That's not good. I thought I had it plugged in. Hold on just a second. I need to find another outlet. There we go. Sorry about that. Okay, where was I? I'm going to spend 2 minutes here talking about Smith charts. Don't be terrified. Smith charts are amazing. I grew up with them as a young physicist and RF engineer. I actually, everybody thinks about them in terms of radio engineering. I actually use them to do quantum mechanics stuff in physics. It's kind of an interesting tool. Anyway, it's this big, complicated-looking thing, but don't let it scare you. The horizontal axis here is the real axis. It's the purely resistive measurement. At the far end of it is open. This intersection here is an open circuit. The near end is a short circuit. And for our purposes, we're calibrated to right in the middle be a 50 ohm measurement. So again, this is the real axis. Above that axis is inductive territory. Below the axis is capacitive territory. Now, the reason, back before, when I had to take a slide rule class in college, before we had calculators and computers, the neat thing about having a plot like this is you can take a ruler, and if you've got a capacitor or an inductive load at a particular, this is the frequency from beginning frequency to end frequency of the sweep here, and a measurement of the complex impedance of the circuit under test. And you can take a straight edge. If you want to correct, come on, oh, shoot. If you want to correct your circuit to 50 ohms of impedance at that particular frequency, you lay a straight edge from that point right across the 50 ohm central line to the same distance out here, and that's the amount of capacitance it takes to counteract the inductance of the circuit up here. So once you've spent a little bit of time with Smith charts, the neat thing about it is if you have this on the same screen with an SWR plot and put the marker at some place of interest on the SWR plot, you can glance the Smith chart and say, oh, it's capacitive right there. I need to add some inductance to it. Okay? So I'm going to talk about Smith charts, but they're a damn near an entire bachelor's degree. Okay, this is my daytime operating station. I'll talk about why I have two in a minute. Not important you see this, but I want to show the antennas that are associated with it. Running SDR play on here, and the VNA here, and my 7300 here, my police scanner here, my VHF, UHF radio up here, and some other stuff. So these are the antennas that are used with that station. This is my tower. That's what I call the storm position at about 25 feet. It cranks up to about 60 feet when I'm actually operating. That's where it goes. But I have a 30-foot whip on top of that that's used for HF with a UNN right here in the base. And then at the side of the house, there's a dual band VHF, UHF antenna. If anybody wants to see an easy way to mount antennas sometime, I'd be happy to talk about it. This is just two pieces of chain link fence top rail with one eye bolt in the wire here, in the wall here, with a rope, 1/8-inch cord hanging down from it that wraps around the post. And I pull it up and tie it to a cleat on the post, and that holds it up. When I want to get it down to work on, I untie it from the cleat and
Chip, you've frozen up.
We seem to have lost Chip.
Well, I guess we'll wait for him to come back. So I guess I have a question for him, which is really kind of a basic, what are we trying to do with a vector network analyzer? We're trying to measure the power that goes into and out of some kind of a junction, and as well as any reflected power. Is that what we're doing? Bob, you might know.
Well,
Trying to fix this glare on the. Like, can you hear me, Greg?
I can, yes.
Okay. Yeah, so I think it'd be fair to compare this to a very basic antenna analyzer. And an antenna analyzer, the simplest ones, you pretty much plug it in, dial up the frequency, and it reads out SWR. And it may plot it for you as well, right? But it's pretty straightforward. This really is a VNA, and so you're going to have to do a little more, I'll say, fiddling with it. And if you're trained in electrical engineering, it's not too bad because you probably have seen these concepts. If you're not, you may go, well, how do I get SWR out of this thing? And what you'll have to do is make a reflection measurement, and that's S11 that Chip was talking about. And then you probably don't want four traces up. And frankly, I don't think you want the Smith chart up either. And you probably just plot SWR versus frequency, and that would give you a nice picture of what your antenna or antenna system is doing.
Good. Good. I wonder if, well, we'll have to see if Chip still shows up on my list. Chip, are you able to hear us?
Chip is working on returning, it says. So, okay, we'll tread water. Okay. The other comment I'll make, I have one of these, right? And I actually found the user interface on the device to be not that great. That's one person's opinion, right? And what people on the interwebs told me, it's like, yeah, forget the user interface on the device. Get the software package, and life will be good. And in fact, I did that, and I was pretty happy with how the software package works. And so I actually use it almost exclusively in that mode. It seems to really help. That's my experience. So I think some of you guys, if you have one of these as well, you might want to chime in.
I think I'm back.
We
Hello?
see and hear you.
Okay, I'm sorry about that. I don't know what happened. Let me.
But while you were gone, Bob just gave us a quick, for some of us, it might be much easier to not have all those traces on and just look at the SWR.
Absolutely.
Over the range of frequency.
I'm going to move to the computer display now, and that makes it much easier.
Perfect. All right.
That's just what I said.
Okay, so yeah, the reason I wanted to show you this was just, it's amazing how much information they cram onto that little bitty display and how good a job they actually do with it. So let's move on here. If I, come on. Yep, here we go. Okay, so this is a look at the computer, that basically the same information on the computer. And I can't, this is a slide, but you can pop each of these windows up, make them as big as you want, and print them out. You can see the markers on here. There's two. And this is all the marker information. So there's marker 2. I'm not going to go into a lot of detail on this, but using this software is really pleasant. It takes a little getting used to, but it's amazingly powerful. So let me go on to the next one. Okay, this is a scan from 1 to 30 megahertz on that whip antenna. This is the SWR, and it lets you very quickly and easily take a look at the entire antenna. This is complex impedance, and again, this is one of those things where I can glance at it and see whether I need capacitance or inductance at a particular frequency. This is kind of, this thing has TDR capability, time domain reflectometry. It's synthesized. So it could, if you've got a cable with sharp bends and faults and connectors, it does a great job of measuring, telling you exactly how far it is to some perturbance in the cable. Neat piece of software. That TDR capability is not in the instrument standalone. You have to have the computer software to do that. Again, this is, let me show you one thing. You see this segments box right here, and I've got a 10 in there? That means it's doing the scan in 10 segments. So it's 100 dots, 100 points times 10. This is 1,000 points of information to give me a smooth trace here. That's sophisticated as hell. Okay, this is that dual band base station. The only reason I'm really showing this is to show all the dots here and just how complicated an SWR sweep can be over a big range. This is 100 to 500 megahertz. So you're going to want to take that down to a narrower range. This is the same thing, 100 to 500 megahertz on the screen of the device, and it's not particularly informative, but it's kind of neat. Okay, so this is just looking at the 70 centimeter band on the display, again with the markers, so I can see that there is a SWR is the yellow trace, so I can see that it's somewhere around 440. Let's see, I don't have that marker shown, but that one's around 440. And the neat thing is then I can look at the complex impedance and number 3 on the Smith chart, which is right there, and see that, oh, that's almost a purely resistive load at that point. So that's why it's so nicely tuned there. Not a lot more detail there. That's just amazing how much information there is on this little display. This is the 2 meter band, and the SWR you can see down here. This is if all you want to look at is SWR. This thing does a great job. The reference down here is 1. This is 2. So I can see that my entire SWR across the 2 meter band is less than 1.5. I can use the markers to see exactly what it is at any point. The horseshoe shape of the Smith chart here is kind of interesting. That tells me that most of the complex impedance here is inductive. So if I want to smooth that out to exactly 50 ohms, I'm going to probably have to add some capacitance to it. Here's the same thing, the 2 meter band on the computer, showing the Smith chart, complex impedance. And again, that I didn't do TDR on here, but if you actually, if I had expanded this, it turns, that cable is 50 yards. And if I expand this, it would show me that cable is just a little over 50 feet long, which is kind of neat. Okay, this is my nighttime station. The reason I can move up here at night is my wife uses the desk I'm sitting at all day to work. So I'm relegated to the downstairs. At night, I can come up here and actually do stuff. This is what you can see behind me here. And can't see it very well, but if this is a Silicon Graphics Octane computer. It's one of my favorite things in the world. And this is a Silicon Graphics Indigo too, which is, it's disturbing that I have that many Silicon Graphics computers. I just got this Heathkit 104A from one of our club members not too long ago, and it's kind of fun to drive. Anyway, the antennas associated with this station are at the other end of the house. A quad band VHF UHF antenna here that actually works pretty well. You can barely see the wires coming off of here. This is the off-center fed dipole that's actually about 170 feet stretched out between 2 trees. And I can tune that to 160 meters, but it gives me good HF match all the way from 160 meters up to 10 meters. So those are the 2 antennas we're going to look at now. This is the 2 meter on that. Again, you'd expect that's a diamond antenna. You would expect it to show pretty good characteristics at 2 meters, and this is the SWR plot, and indeed it does. This is that quad band shown on the computer, and it's the same information. It is interesting on the TDR plot here. If you look at this is 26 meters, and that is in fact a 50-foot cable. So it's Given that there's an antenna on the end of it, the TDR is not going to be terribly accurate, but the fact that it's that close is pretty impressive, actually. And again, all of that marker information is just amazing to me. And you can add as many more markers to this as you want to. It gets confusing. This is the off-center fed dipole at the 40-meter band. And again, this is SWR, Smith chart to show what the complex impedance is. This is a return loss in this case. So it's a glance at this gives you much more information than just an SWR plot would, but it's still pretty intuitive. And this is that off-center fed dipole swept from 1 to 30 megahertz, again with 1,000 points of resolution. The Smith chart here is not terribly helpful, but if you wanted to see what was going on at some point here and what I needed to do to correct it, I could move a marker to that point. The marker would be at the same place on the Smith chart, and I could use that to make a pretty good estimate of what I needed to do to it to correct the antenna at that point. Okay, so that's all I'm going to talk about antennas at this point. One of the other neat things, the simplest 2-port device you can test is a cable. So I've got a cable hooked up here. The Smith chart on this is meaningless, so we'll go on. But this is a 50-foot Belden RG8 mini cable, so it's a pretty good cable. And if I now look at this, just all I'm really interested in this is what the loss versus frequency is. And loss is the inverse of gain. It doesn't actually have a loss format, but gain is exactly the same thing. So I can look here from, in this case, I think it's 1 megahertz out to 500 megahertz, and see that by the time I get out around 400 megahertz, I'm down about 4 dB, which is over half of my power that I'm transmitting. So it's a great way to do a quick estimation of cable quality. Great cable tester along with SWR. And here's the TDR plot. Now, when the TDR plot starts to get interesting, and this is saying 19.8 meters, so about 19 meters is where the transition is. That's the connector going into port 2 on the instrument. Here's that same cable with the end disconnected from the port 2 on the instrument. And the only reason this is interesting is for the TDR plot. Now you can see exactly where the end of the cable is. And this is in meters, and that's 19.8 meters, and it's a little below that. So if you change this to feet, it's 50 feet. TDR instruments all by themselves used to sell for $20,000. This thing, it just does it. Okay. Oops, hold on. I missed some in here somewhere. Maybe I didn't. I guess I didn't. Okay. Takeaways from all this. I'm amazed with this thing. It's this is my Walmart NanoVNA. Let me see if I can get it here where you can see it. I'm going to put it in the club's equipment pool if people want to use it. I got another one. And with the NanoVNA Saver program, under $100 VNA, this thing's mind-boggling to me. I would say that this NanoVNA and a decent digital multimeter meets 95% of ham testing needs. I've got at least probably closer to a dozen antenna analyzer and SWR meters. I probably won't be using them again. I like this thing. If you're just going to use it for SWR and cable testing, eminently justifiable. You don't need to worry about Smith charts or any of the rest of that crap. If you're going to buy one of these, check the reviews. There are dozens of different Chinese outfits making these things. Some of them are really, really good. Some of them are not really, really good. Check the reviews. Pay a little bit more and get the full case where my Walmart one has, I don't know if you can see this, It's an open plexiglass case, which causes some RFI problems and makes it not quite as durable, I think. Pay $5 more and get one with the full plastic case. Again, pay a little bit more and get one with cables and the calibrators, because if you buy the calibrators separately, they cost a lot more. Order adapters when you order your unit, because you're going to want to play with it right away. It has SMA connectors, and if you don't have the adapters, you're going to have to wait till you get them. If you you can buy sets of adapters. It's cheaper to buy them that way. Get more than you need, because you're going to find other stuff to hook this up to. Okay. Finally, the user interface is very usable, much better than I usually anticipate from Oriental manufacturer. Does take a little getting used to. Get a stylus. Okay, I'm going to kill this part, and then we can talk for just a second. And if you would like to, here we go. I will then. I've got the NanoVNA hooked up to my computer, and I actually run it here for just a minute if anybody wants to see it live. Do I have any feel for that? You want me to take 2 minutes and show it live? Greg, I'll go with your advice here.
Sure, go ahead. Show us. And then kind of a basic question, which some of the people may have is,
go ahead.
Why don't you just explain just a little more detail what a vector network analyzer does specifically? And, and then why don't you talk about a little bit about VSWR and explain why that network analyzer is good at showing you information that is helpful when you have SWR.
Okay. Yeah, we talk about SWR all the time, and VSWR is just voltage SWR. And standing wave SWR standing wave ratio, it's basically a measure of how much energy is getting reflected back from whatever your transmitter is pushing out at the end of the cable, the antenna. And it's reducing VSR to a 1-to-1 ratio, which is perfect, doesn't mean you're transmitting all your energy, because a dummy load with a big resistor does a great job of giving you a perfect SWR, but it doesn't transmit anything. But the main thing it does is let you know if your transmitter can be happy transmitting, putting out full power into the antenna system. Okay, so let me start up real quickly here.
Chip, if I may interrupt.
Yeah.
I believe Lauren, K0CHP, has his hand raised.
Okay. Let's see, Lauren, I don't have you on here. Hold on a minute. Go ahead and hit your space
Sure,
bar.
Chip.
There you go.
What I was going to ask, and I think I know the answer, but where this could also be useful, and not necessarily with cables or antennas, is measuring impedance matching, so that if you're building a kit and you're winding toroids and you want to know, do I have the matching networks correct? Because I know there's a number of kit builders who built the BitX or the QCX devices from QRP Labs. But if you're winding these things, you can terminate one of those cables into your matching network and put a 50 ohm resistor at the other end of it and find out if it's actually matching correctly. You can find out what the resonant frequency is. So, or if you're building filters, you can start to see where the cutoff points are with these devices.
Absolutely.
Is that correct?
Absolutely. That's an excellent point. And in fact, beyond that, if you're winding your own toroids, you've probably run into discussion about what cores to use. And that is a big, big problem, is getting cores that are effective for the frequency band of interest. And this thing is excellent for characterizing toroids like that, looking at loss and transmission across a network consisting of toroid. Somebody asked about whether this can be used as an oscilloscope, and the answer to that is no. That's a different kind of problem. It's kind of an interesting question. It's quite possible you could write some software for it to do it, but I'm going to let go of the space bar here. Somebody nod if I'm still talking. Oops. Hold on. Can you still hear me?
Oh yeah, we can hear you.
Okay. Did I bring it up? Oh, well, any of you have heard me talk about test instruments will have seen me talk about the micro bit X oscilloscope. They're around $130. It's a USB device, 2-channel spectrum analyzer, just a great high-speed A to D. If you want a really, really good oscilloscope, don't want to spend a lot of money for it, and have a computer you like to use, the micro bit X is amazing. Logic analysis, spectrum analysis, high-speed digital dual-channel scope. If you want an oscilloscope, I'd look in that direction. But no, the VNA is not going to give you oscilloscope kind of capability in general. Okay. See that. Let me start up the software here real quickly, and I'll share that. Okay, so that's running. So I just need to share screen. This guy. Okay, so here we are. You okay? Did I get somebody? Steve, you okay? Too much light?
We're good.
Okay. All I want to show you about it here is a live sweep. This is of, again, I believe, hell, what have I got it hooked up to? That's my quad band antenna. See, I don't know if you, this is the VNA here. You can see it. And my quad band antenna going into it and USB cable coming clear over here. So if I do a sweep now, you're going to see it build up those 10 segments. And there we go, 1,000 data points from 50 to 450 megahertz, characterizing my quad band antenna. And if I put a marker on here and start it, you can see I've got one resonant point there at, that's marker 1. So that's 120 megahertz. You can't see it very well, but this is a quad band built for the 8900. So it has 50 megahertz band. And at 50 megahertz, the SWR is around 1.5. So that's pretty excellent. This is the 2-meter band, or pretty close to it, 145 megahertz. And again, you can see it's pretty close to 1-to-1 matching there. 220 megahertz band. You see the frequency here, close to 220. And the SWR, 1.128. And finally, up here at the 440 band, but 435, let me move it up just a little bit. There's 441 megahertz, SWR 1.081. This is and let me turn off some of the other displays here. We'll turn off the Smith chart because it's too damn busy to be useful for anything anyway. And turn off the TDR. And turn off the complex impedance. And now I get a big display of my SWR, standing wave ratio. So this is the information, this is the energy reflected from the antenna. And any place it's real high, that means there's a lot of energy being reflected, and it's not going to my transmitter's not going to be very happy there. But this point is at 91 megahertz. I'm unlikely to be transmitting there anyway. So at the next meeting we have where we get together, I will bring one of these along with some stuff to measure and play with. And if anybody wants to play with one, I'm going to turn this off now. I'll be happy to help them. I'm going to have one in the club equipment pool. If anybody wants to check it out, they're welcome to. To use it, just the instrument manually, to just do SWR is going to take probably a few more steps, touches on the screen than it would with a simple SWR meter. But it's cheaper than an SWR meter. It gives you everything. Okay, I'm done. Thank you.
Thanks, Chip. Anybody else have any questions? I guess I haven't been following the chat window very closely.
Yeah, I haven't either. Let me take a look over there.
Yeah.
Barbara notes this is good with wine.
Chip, what's the upper frequency limit?
900 megahertz, and there are some things being done to extend it. It's 50 kilohertz to 900 megahertz, and it turns on with that sweep. Now, again, keep in mind it's a square wave that it's using to test. So if you're trying to characterize with great precision low noise amplifiers, this is probably not the right tool. It'll give you a good, quick, and dirty handle on it. But and I will get the slide set over to Steve. It's a little bit too large for me to email right now, but I'll get it over to you so that you can post it somewhere. See any?
So, Chip, when you use this, if you just wanted to check, say, 20 meters, you could set your zero or your beginning frequency and the end frequency to get the whole 20-meter band, and then focus the SWR chart really in there and see where you're below your 1.5.
Exactly. Yeah. No, I can't get over what you're getting here for under $100. It's as an old instruments guy, this is just amazing.
Well, thanks, Chip. Appreciate that.
Chip, Heidi has a question here.
Yeah. Go ahead, Heidi.
Heidi.
I can't hear you yet.
Push to talk.
Push your space bar down.
I'll try it that way.
Well, Heidi, there we go.
Yeah, the space bar wasn't working, but
Yep.
Not sure which question, but I constantly come back to a simple example. You said this doesn't do good at tuning antennas, but maybe that would wet our whistle, so to speak.
No, it's excellent for tuning antennas. I love it for that.
And if you did bring it to the club meeting in person, that would be really cool.
Sure.
To just see it, so that you can get wet our whistle, so to speak. Not just with my
Yep.
my beverage here.
Yeah. No, that's an excellent idea. I've already gone over time, or I would have put in some other stuff to measure, just because it's fun to measure. But yeah, that's a really good idea, and I will bring them to meetings so we can play with them.
Yeah, and me, like you, I remember when things that do things that my watch did that cost $100,000.
Yeah.
Thank you, Chip.
My pleasure.
Well, I think that's it. Unless anybody else has questions, maybe we can adjourn.
I would say there's Troy observed that maybe Chip could put together a couple links for VNA you recommend with adapters and stuff, and maybe
Sure.
share it with it all.
I hate to be in a position of recommending from between particular vendors. I would highly recommend just going to Amazon, find one that has the adapters and everything, and make sure it has, say, at least 20 reviews and that they're pretty good. If you do that, you're probably going to be okay.
Right. Thank you, Chip.
And they are inexpensive, and we will have one at the club that people can use and try out. Is the software downloadable by anybody?
Yeah.
Chip?
It's not an installer. It's not a classic Windows installer. It just downloads the executable.
Mm-hmm.
So you'll probably want to put a link to it on your desktop, or put the actual executable on your desktop. So it's not quite as convenient as modern Windows programs, but you just need to understand that it's not a big deal. And as I said, there is a version available for Mac that apparently is pretty much as full featured as the Windows version, and the source code's available for compiling in any different Unix you may be interested in. And there is an app on the Play Store for your Android phone that's actually pretty darn good.
And do they take SSD cards, or how do you how do you save the information if you're out in the field? And
It actually, in the menu choices, it has a place to save 1 or 2 complete screens. Basically, it's a bunch of data points, 100 data points that it saves.
Okay.
And then you can read that into the software after the fact. But it doesn't have a lot of storage on board, no.
Okay. Anybody, any questions? Well, I guess we should congratulate Stephen for making this all work.
Absolutely.
It's no small task. Thank you. And Chip, thank you for volunteering to be the guinea pig tonight.
I think I went a little bit long. Actually, not too bad. 8:40, so I guess not too bad.
All right. Well, we don't all have to drive home. That's the nice thing. So,
Absolutely. Yeah, and I will get this presentation to Steve along with some other information so we can get it posted. And I'll get to work on the club's equipment pool so that we've got a place to get into that stuff again.
Okay. We really just have the club portable station, right, which is the 7300. And
no, we've got this VNA, a SWR meter, a handy talkie, a power supply, and Bob may be interested in this if he's still on there. Let me see if I can. Can you see me there?
Okay.
Let me do this.
Once you hold it in place, we'll be able to see it.
Okay.
This
is the mini Lime SDR. It's finally available.
Wow.
This is a DC to daylight SDR with a transmitter, 100 milliwatts transmitter. Slick as hell.
FPGA, right?
Very cool. Mini Lime finally is out. Wow.
And how does the programming software work? Have you played around with
that? It will confess to a certain level of disappointment.
The software.
The 2 softwares that work with it are SDR Console, which is pretty good, and SDR Angel, which is a new package. And I haven't been able to get it to work yet.
So for those of you that aren't familiar, maybe Chip can spend 2 seconds and explain what an FPGA is. In my layman's terms, it's where you have software that you can write to create hardware.
Yeah.
And then it basically pretends that it's hardware.
Yep.
So if you want to add a capacitor, you just change the program and add a capacitor.
FPGA means Field Programmable Gate Array, and it's a big chunk of logic gates with other stuff that you can switch in and out of a circuit. You can build a circuit in code, download it to the FPGA, and implement the circuit. And this Lime SDR has a really high performance analog to digital converter, digital to analog converter for transmit, some filters and other stuff, plus the FPGA that you can program to do anything you can imagine doing with a receiver and a transmitter. The upside of it, it's one of those things that Hewlett-Packard, we used to say the road to total uselessness, if paved with complete flexibility. And this is one of those devices. Unlike SDR Play, for example, which you get out of the box, you connect it to your computer, and you're on the air. You're not quite going to do that with the Lime SDR.
Well, I'd heard rumors that some of these have a pretty sophisticated graphical user interface that'll allow you to kind of create like an audio amplifier and just drop it in.
Yep.
And if you want an RF amp, you want to add a bandpass filter, you just plug those in, and then it figures out all of the underlying programming. And then I assume there's some kind of an optimization routine you run through, and it lays out the board for you, and then boom, you're up and running.
Yeah, we've got a question here about whether it's will work with GNU radio, and the answer is yes. It takes a little bit of work to get it to do that. And as you were talking about, Greg, the Lime organization, it's a crowdsource funded project. The Lime organization has provided a configuration and programming tool for this thing that I have just begun to dive into, and it's one of the most complicated and tedious things to actually get into and do things with I've ever run into. In all honesty, I think that is a little bit above the level anything we want to try to present at the club. It's an engineering exercise. At this point, I would not recommend the Lime SDR for, let's say, the casual or entry user.
And how much are they?
The Mini is around $180. It has one transmitter and one receiver. The full Lime SDR has 6 receivers and 4 transmitters, I think, that are all independently programmable. Trying to program this thing was bad enough. I can't imagine. It's targeted at people trying to do Wi-Fi or Bluetooth or development in those areas, but it's eminently useful for amateur radio operators as well. It's just the learning curve is steep and long.
All right, well, great, thanks. All right, if we don't have anything else, I say we should just adjourn, and we'll plan on doing this again in May, although there's a possibility we'll be able to hold the meeting live at the same time. And we'll hopefully be able to figure out a way to allow streaming for those that can't or don't want to come to the meeting until we get really some kind of inoculation that takes care of this COVID thing. I suspect people will be more cautious about big meetings.